You have 50 feet of Christmas lighting with which you wish to create an entrance to your Christmas party with. The entrance will have a semicircle arch at the top. Let X represent the width of the entrance and Y represent the height. So this length all across here is going to be X, and our height will be Y. Sorry for the pause, I had to take a quick call from my husband. Okay, express the radius of the semicircle in terms of X. Express the radius of the semicircle in terms of X. Okay, so the radius, the diameter is a length of X, but the radius is only half the diameter, so I'm going to do half of X. Express the total distance of the Christmas lights in terms of X and Y. So this entire part in terms of X and Y. Well, we have two Y's, both on the left and on the right, so I have 2Y plus, and now I need to go half of a circle. So the outside of the circle is known as the circumference. Now I only want to do half of the circumference because I have half of a circle. Circumference is 2 pi, and normally I would write R. R is the radius, and we can see up here radius is going to be described as 1/2 X. So let's simplify this. 1/2 times 1/2 is going to be 1/4 because I'm multiplying the numerators and the denominators. So this gives us 1/4, but we still have that 2 out front. So I have 2 times 1/4 is going to be 1/2. So I end up with 1/2 pi X plus 2Y. And this will help us to express as an expression the total distance of the Christmas lights in terms of X and in terms of Y. Okay, now we're going to express the height. So I want to express Y in terms of X. So I know this is the entire part. I know this 50 feet of Christmas lights will go over this entire. So this length from here all the way over here is 50. So let me grab a different piece of paper where I can show my work and have a little more space as I do part C. So I'm going to take 50 and I'm going to set it equal to, I have 2Y plus 1/2 pi X. And I want to isolate the Y. So I'm going to start by taking this region and subtracting to the other side. So I have 50 subtract 1 pi X over 2 equals 2Y. Now I'm going to divide by 2. And dividing by 2 is like multiplying by 1/2. Whatever I do to the right, I must also do to the left. So I have 1/2, because dividing by 2 is the same as multiplying by 1/2, times the quantity 50 minus 1/2 pi X. And so I've isolated the Y, but we can simplify this. So I need to distribute the 1/2 to both quantities on the inside. Half of 50 is 25. And when you take half of a half, that means we need to multiply. So 1 times 1 is 1, 2 times 2 is 4. And now I have been able to express the height of this in terms of X. Express the height of the entrance in terms of X. By the way, you may have also seen a different answer. A different answer may have looked like this. It may have been, I think that Mr. McFarland left his answer like this. But this is equivalent to this. Watch. 100 divided by 4 is 25, and then we have pi X over 4. I prefer this, but they're equivalent. Let's go on to part D. Express the area of the rectangle as a function of X. Let me grab a I actually want to leave this up here too. So we want to express the area. Okay, so as a function, that's the key, as a function. So as a function here, here's the area. Now we want to do the area of this rectangle, and we want only the variables X. So we're going to do length times width. We can tell that the width is X. Now the length here is going to be Y, but we don't want to put in the variable Y because we want to express it in terms of X. So here we can see down here, this is going to be, if I move this down, this is going to be the length in terms of Y. Okay, this is the length, this is the length of Y, but expressed in terms of X. So instead of putting Y, I'm going to put what Y is equivalent to, which is 25 minus 1 pi X over 4. Let's go on to the next one. What is the domain? So I'm going to set each of these equal to 0. So X equals 0. And I'm going to take this quantity, 25 minus 1 pi X over 4, and also set it equal to 0. So let's work on now getting X equal or x, we're going to isolate it. So to isolate the x, I'm going to start by subtracting 25 from both the left and the right. And I have negative 1/4 pi x. 0 minus 25 is a negative 25. Now, to remove the fraction, I'm going to multiply by the reciprocal. So 4 over negative 1 times 4 over negative 1. I get pi x equals negative 25 times 4 is negative 100 over negative 1. So pi x equals positive 100. Two negatives make a positive. And then I divide by pi. So I have 100 over pi. So the domain needs to be greater than 0 but less than 100 over pi. Now I'm going to grab the calculator, and I've already taken time to plug in the function for area in terms of x. And so I'm going to graph it, and I'm going to demonstrate how we can see that the solutions here on this problem, or the x-intercepts, will help us in determining the domain. So if I do second trace value, we can see that yes, one of them is at 0, and second trace value, 100 divided by pi. Let me find the pi symbol here. Here it is. So 100 divided by pi is also 0. So we can see that it is between 0. Oh, I'm so sorry. I'm never moving that up. It is between 0 to 100 over pi. If you did not see that because I didn't look up above, second trace value, we can see 0 is a solution. Second trace value. I did it algebraically, like I'd like to see you do it as well, but we can also see it's a 0 by looking at the graph. So the area here is between 0 to 100 over pi. Don't give me a decimal, please give me 100 over pi. That's what we have right here. Let's go on to the next question. The next question is, find the area when the width, so we're talking about this, find the area of this when the width of the entrance, so this width is going to be 2. I'm going to go back to what we have here, and I'm going to plug in a 2. So I substitute 2 in here, I substitute 2 in here, I do the math, and I figure it out, or we can graph a graphing calculator. And remember, x here, x represents 2. So second trace value, substitute in 2, and we can see our area is 46. Let's round to the nearest hundredth, 46.86. And what are the units? Feet squared. Now we could also get 46.86 by coming up here, again going up here, plugging 2 in here, plugging 2 in here, and doing the math. Let's just demonstrate how that does work. So we have 2, and then I have 25 subtract 1 times pi times 2 divided by 4. Oh, I messed up with my parentheses. Try one more time here. 2 is the first part, and then it's going to be 25 subtract 1 times pi times 2. Okay, and then I'm going to divide that by 4. 1, 2, 3, and it should be right there. There we go, 46.86. So whether I use technology and I go second trace value, or I just plug it in, I get the exact same answer. Let's go on right now to finding the maximum area. So maximum area is going to be right here. So second trace, making sure you guys can see this, second trace value. So I'm going to go left bound and right bound. So somewhere to the left, pressing enter. Somewhere to the right, pressing enter, coming all the way up and over. Back to the highest point. Remember, x here is going to be, this is going to be our x value, which is the diameter or the width of this entrance. And then this is going to be the maximum area. So maximum area is going to be 198.94 feet squared. And our last question here is determine the dimensions that you will produce from this. So we have a dimensions, we have 15.92 if I round. So 15.92, that is our x. Now let's figure out what the y is. Now how do I figure out the y? I come back to what y was. So here's our y, and I'm going to plug in here 15.92. 25 subtract, and I'm going to go 1 times pi times 15.92, and then I'm going to divide this by 4, and we should get 12 point, it rounds up, so 12.5.